Good morning or evening at whatever time you're listening to this. We're going to learn how to do loft sines and loft cosines, but before we do both of those, we're going to find area using different formulas than you're used to for triangles. So previously you've learned for triangles that the area of a triangle is 1/2 base times height, which does work. But there's also other formulas that work now that you're in advanced math. There's different things that you can use. Before we get into the actual area of a triangle, let's just make sure and double check that you guys know how to put these in your calculator. Make sure your calculator is on degree mode. And you'll know if it's on degree mode when you put the following values into your calculator and if you get the same numbers that I do. So you should do them right now. Maybe pause the video and then we'll put them in. So for the first one, you should have -0.5774 if you're going to 4 decimal places. For the second one, even though sine of 120 is on the unit circle, which is radical 3/2, this you're just going to put this in your calculator to get a decimal. So 0.8660, and yes, the 0 is necessary if you're going to 4 numbers. And for the last one, when you put that in, you should get -0.0872. If you are not getting those numbers, you're either putting them in your calculator wrong or it's in the wrong mode. So check that. I'm not going to do the next 3 problems. We're going to go ahead and go to area. So to use these formulas here for area, as long as you know 2 sides of a triangle and the angle in between, then you can use these formulas. So it's basically 1/2 times the 2 sides times sine of whatever angle's given. So to put that in your calculator, or to double check, let's say. So in this case, they give us 2 sides and the angle in between. So it doesn't even really matter what the names of those sides are, whether it's A, B, C, D, E, F, whatever the names of the triangle are. As long as you know that you have 2 sides and the angle in between, you can use this formula. When you write it down, it will be area equals 1/2 one of the sides times the other side times the sine of the angle that's in between. When you punch that all into your calculator, all at once, you should have 114.2 units squared. You do have to put units squared, but because we're talking about area, the order in which you put those in does not matter as long as they're all multiplied together. Instead of 1/2, I actually put 0.5 in my calculator when I'm putting it in. It makes it a little bit easier than putting in 1/2. Or the other option is to do 19 times 17 times sine of 35, and then at the end, just divide that by 2. It will give you the same result. I'm going to take a second, and you should do the next one on your own. So you might want to pause the video, and then I'm going to go ahead and go into doing the next problem as well. Okay, now that you've had a little bit of time, or as much time as you needed, we have 2 sides, and we have the angle in between. So the area, and I would like you, if you were doing this in class, to write the entire formula, equals, and instead of A, I put area because there's already an A. I didn't want to get those 2 things confused. So anyway, we want 1/2 times 12 times 15 times the sine of 110. And again, if you put those all into your calculator, you should have 84.6 units squared. We don't have units, so I just use the letter U for units squared. In this case, to save a little time, you could just put 6, which is half of 12, times 15, times sine of 110. After this point, we're going to skip the loft sines for now. We're going to section 9.4. So right now we're in section 9.3. I want you to go ahead and go to 9.4 in your notes. And then in 9.4, we're going to go down to example 4. All right, so finding area of a triangle using this formula is called Heron's formula. And what we use is we use the semi-perimeter. So the semi-perimeter or the half perimeter is basically exactly what it sounds like, is the perimeter of this triangle, but then we divide it by 2. So first thing I'm going to do is I'm going to find the perimeter of this triangle. So I'm going to add, and this is the area formula we're going to use. I'm going to show you how to do that in a minute. Okay, the easiest way to set that up. It's basically the semi-perimeter times the semi-perimeter minus each of the sides, and you're going to take the square root of that. So the perimeter is adding all the sides together, 170 plus 240 plus 350. So the perimeter is 760. So if you divide that by 2, the semi-perimeter is 380. That's the number that you really need to work with. To find the area, we're going to have 380 times 3 values. And those 3 values are basically 380 minus each of the sides. So it'll be 380 minus the 170, which is the first side. It'll be 380 minus 240, which is the second side. And it will be 380 minus 350, which is the third side. Next, you're going to multiply all those numbers together, and I would like you to put in the entire value when you multiply those out. So when you multiply all those numbers together, you're going to get 335,000 or 335 million, 160, and then 1,000. And you put that in your calculator, and that should give you about 18,307.4 yards squared. So those are pretty big numbers because these are also big. So if you're counting how many yards are in here, how many square yards are in there, there's going to be about 18,300 square yards. We're going to do one more problem. I would like you to try it first, and then I'll put in the results. So again, pause the video right now, and we'll do the next problem. Or you'll do the next problem, and then you can check it. So for the last question, example 4 that we're going to do on this lesson, the perimeter is 11 plus 17 plus 20, which is 48. The semi-perimeter is half of that, which is 24. So the area will be the semi-perimeter, 24, the semi-perimeter minus the first one, which is 13. The semi-perimeter minus the second length of the side, which is 7. And the semi-perimeter minus the last one, which is 4. So if you multiply all those together, you should get 8736, and that should give you 94.5 centimeters squared. So in today's video, I'm going to show you how to solve a triangle for all 3 sides and all 3 angles using the law of sines. The law of sines, we're in section 9.3 right now on example 3. The law of sines that we're going to be using is that sine of A over A is equal to sine of B over B, sine of C over C. So the capital letters refer to the angles, and the lowercase letter represents the sides across from those angles. So if this is angle A, the side across from it is side A. If that's angle B, the side across from it is side B. And then because this one's angle C, then the side across from it is side C. And when we were doing SOHCAHTOA before, angle C was always a right angle. In this case, all the angles are going to be completely different. They can be acute, they can be obtuse, they can be right. We don't know what they are, but we're going to solve this. In order to use law of sines, you need to know 2 angles. Or if you only know one angle, then you need to definitely know the side that's across from it. So if you only know one angle, then you must know the side that's across from it. So we're going to go ahead and solve these. If they give you 2 angles, like in the first few examples that we're going to do, then there will only be one triangle. When we get later on, it's possible that there's more than one triangle, and I'll explain that when we get to that point. So let's go ahead and fill in the values that we know. So B is 25 degrees. C is 107 degrees. And side B is 15. You can draw the picture if you want. It's not really necessary. Since we know side B and angle B, then we're going to definitely use that part of the formula twice. The first thing we're going to do is find angle A just by adding those two, 25 and 107, and subtracting them from 180. So that gives me 48 degrees for angle A. I will be doing some of these computations ahead of time, so if you want to stop the video and do some of the work yourself before I explain it, you can go ahead and do that. So let me set up this formula. Again, this is going to be the given information, so that's the part we're going to start with. So sine of 25 over 15, that's sine of B over B. And then I'm going to say that that equals the sine of A, which is 48, over A. And we're going to solve this, and I'm going to explain that in a second. We're also going to do the same thing for our angle C. So we're going to start off with sine of B over B, so sine of 25 over 15 equals, and then for C, we'll do sine of 107 over C. When we solve these, we're going to cross multiply. So we're going to multiply these two together, the two ones that have a number, and then we're going to divide by sine of 25. So again, we're going to cross multiply. I will write it out this first time, but after this first problem, we're just going to do the math in our calculators. So if you cross multiply here, you get sine of 48 times 15 equals the sine of 25 times A. And then in order to solve for A, we'll divide both sides by sine of 25. So you can see this is just a proportion. So it's these two multiplied together divided by that one. So sine of 48 times 15 divided by sine of 25. And that's going to happen all the time that you're doing this. So this one will be sine of 107 times 15 divided by sine of 25. You do not have to write all of this out in the future. You can just do the whole thing in your calculator all at once. So if you put all of this in your calculator at one time, sine of 48 times 15 divided by 25, you will get A is equal to 26.4 approximately. We're going to round that to the 10th place, if I could write. 26.4, and we write that in here. Again, same thing here in this problem. We're going to multiply these two together and then divide by that. So I'm just going to go ahead and run that through my calculator. You guys go ahead and do it. See what you get. I'm going to wait a second. Run that through. Sine of 107 times 15 divided by sine of 25. If you ran that through correctly, you should get 33.9. It's always good to check that the biggest angle has the longest side across from it, and the smallest angle has the shortest side across from it. If that's not the case, then something's wrong in the problem that you did, because it should always go that way. Longest side across from the biggest angle, shortest side across from the smallest angle. Let me go ahead and do the next one. You might want to go ahead and try it ahead of me. Pause the video, do the work. I'm going to set up the equations and write the answers in. So right now would be a good time to pause. And I will do that for the next 3 problems actually. So do as many of them as you want for the next 3 problems. I'm going to write the answers in and explain a little bit as I go. So first I'm just going to write these in. Then I'll use my calculator, add these two. subtract from 180. Then I'm going to set up the equations. Since again, B has all the values, we're going to use that. So sine of A over A. The same thing here. Sine of B over B. Sine of 60 over C, which is sine of C over C. We'll cross multiply, so multiply those two together, divide by sine of 49. That should give you 26.3. Very similar to the last question. I almost thought I was doing it wrong for a second. And then same thing here, you're going to multiply these two together and divide by sine of 49. You should have 24.1. These values are much more closely related because these angles are much closer to each other. They're only like 10 degrees apart from each other. So these numbers are very close together as well. Where here, there's a big discrepancy, between the angles, so also between the sides. All right, for the next ones, I'm going to go ahead and just write in the answers. So A was 29 degrees, 85 degrees, and 66 degrees. And here you should have 4.4, 9, and 8.3. The formula you could have is sine of 29 over A. I'm just going to go ahead and put this one in the middle. This is the one that you're going to be using for both, which is sine of 85 over 9. And that equals sine of 66 over C. Since this is the value that you know both the angle and the side, then that's the one that gets used for both. So basically you're going to cross multiply here and get an answer to get for A, and then you'll cross multiply with these two to get an answer for C. And those are the answers. I just hope that you guys just went ahead and did the problems before me. Same thing here. I'm just going to go ahead and give you the answers. Hopefully you did these already. If you didn't, again, you should probably pause and go ahead and do the problem ahead of time. Okay, so for this one, A would be 29 degrees, 70 degrees, and 81 degrees. This is 10. This is 19.4 for B, and for C, it's 20.4. In this case, the value that you have is A. So I'm going to put that one in the middle. So sine of 29 over 10 will be the equation that you use for both. For B, will be sine of 70 over B. And for C, it'll be sine of 81 over C. Again, cross multiply here. So you'll multiply, not those two, excuse me. The ones that have numbers on them get multiplied. So you multiply these two together and then divide by sine of 29. And when you go over here, you're going to multiply these two together and then divide by sine of 29. Okay, so you're doing each one individually. Always cross multiply first on the two values that actually have numbers in there, and then divide by sine of 29. If you rather set up two separate equations and it makes more sense to you, then go ahead and do it that way. So we're still solving triangles using lost signs. And this time they're going to give us one angle only. So we're going to get two sides and one angle, and we're going to have to solve for the triangle. If the angle that they give you is obtuse, then you're either going to have no triangle at all, if that side is too short, or you're going to have one triangle. And we'll talk about that when we go do the problems. If the angle that they give you is acute, then it's possible that you will not have a triangle, like the side that they give you is just too short and it would not complete the triangle. It's possible that there's one triangle, but there's also a possibility that it could form two separate types of triangles. And because of that, since we don't know if that last side is going to hit closer to make an obtuse triangle or hit further out to make a regular acute triangle, then we have to accommodate for both. And so we're going to go ahead and do that mathematically. So for the first problem, the angle is, obtuse. That means I know for sure that it's either going to be no triangle or it's going to be one triangle, but it's definitely not going to be two triangles. So they give us angle A and side A. That's important for law signs. If they don't give you an angle and a side that are the same letter, you cannot solve. And then we have side B. So we have to do sine of A, which is 115, over A, which is 20. And then we have to solve for sine of B because we don't have any information for angle C or side C at all. So sine of B over 11. When we cross multiply here, we're going to multiply sine of 15 times 11, and then we're going to divide by 20. When you do that, I want you to write down what sine of B will equal. So after we divide by 20, we're going to get that sine of B is equal to 0.498 and a whole bunch of other numbers. Leave those in your calculator. In order to solve this, we're now going to use inverse sine of both sides. So if your calculator works backwards, all you have to do is hit inverse sine right now and you'll get your answer. If your calculator works in the normal direction, then you're going to do inverse sine of your last answer. So you're going to leave that in your calculator. So make sure you look for the answer button. If you can't find that, then just use 3 or 4 decimals after 3 or 4 numbers, after the decimal before you do inverse sine of that. The ... here indicates that I'm going to use all numbers in my calculator before I put those in. And when I do that, I'm going to get 29.9. So that's going to be my answer for angle B, 29.9 degrees. Again, I don't have to check for a second triangle because the original angle that they gave me was obtuse, and so therefore I don't have to do that. Now all I have to do is add the 2 angles that I've found so far, subtract them from 180 to get the missing last angle, which is 35.1 degrees. And then to finish off, I'm just going to use law of sines like we did in the previous. So we're going to use those two. So the given information, so we're going to use sine of 115 over 20, and that equals sine of 35.1 over C. We'll cross multiply those two together, divide by sine of 15, and you should get C is equal to 12.7. And that's that. So go ahead and try the next one on your own and see how you do there. In this case, you can pause the video. They give us angle B and it's 70 degrees, which is not obtuse. So I am actually going to go over this with you and show you how you would check for a second triangle. Let's go ahead and set this up. With the given information. And I'm actually going to set up a second triangle because we need to check to see if there is a second triangle. That is not obtuse, which means that it's possible that we have a second triangle. So B is 70 degrees. Side B is 36 and side C is 18. So this is triangle 1. And then this is possibly triangle 2 if we have the right information. And like I said, I'm going to cover that right now. Because they give us angle B and side B, we definitely have to use that. And then because we have side C, we're going to have to solve for angle C first. So the first thing is going to be sine of b over b, which is sine of 70 over 36, equals sine of c over 18. And again, we're going to cross multiply, so you're going to multiply this times this, and sine of 70 times 18, and then you're going to divide by 36. That's going to give you sine of c is equal to 0.469 and then some other numbers. You're going to take the inverse sine of both sides. And you're going to get c is approximately 28.0 degrees. That's c for the first triangle. Now, to get c for the second triangle is you take this and you subtract the original. So you're going to take 180 minus 28.0. So C2 will be 152.0 degrees. That's this one. So C2 is 152.0 degrees. The reason that I know that I don't have a second triangle is because these two angles are over 180 degrees. That means that it's impossible to get angle A. You cannot have a triangle that has more than 180 degrees, so there is no second triangle, okay? Therefore, we're just going to finish the first triangle. So this one, we do have two angles that are less than 180, 70 and 28. So the third angle, if you add those up and subtract from 180, is going to be 82 degrees. We still have to put the 0.0 because it's not an exact number, because that's not an exact number, the 28.0. And then we're going to finish this off. We still have to use the original given numbers as one of our fractions. So sine of 70 over 36 is equal to sine of 82 over a, cross multiply. So we multiply these two together. And we're going to divide by sine of 70. And when we do that, after we solve, we get a is equal to 37.9. And again, the longest side is across from the biggest angle, and the shortest side is across from the shortest angle. Next, we're going to do exactly the same thing here. So we have A, B, C. I would normally write down a second triangle here. Obviously, this says examining a case with no solution, so I already know that there's not going to be a second triangle. But normally, if this angle was acute, I would try for a second triangle. I would just go ahead and write down the ABC, ABC. So A is 51 degrees. Side A is 3.5. Side B is 5. So when you do the loft signs, you're going to get sine of, 51 over 3.5 equals sine of B over 5. When you put that into your calculator, you're going to get sine of B is equal to 1.1 and then a whole bunch of other numbers. If that number here is greater than 1, you will not be able to take you're going to get an error when you put that in your calculator. So when you put that in your calculator gives you an error. For us, that means that's undefined. So there is no B value, which basically means we have no triangle. Okay, so there is no triangle that can be formed with the given variables. If you try the next example, go ahead and put those numbers into your calculator. You might want to pause the video so you can do it before I do the problem. And come back when you're done doing it yourself. So B is equal to 40 degrees, A is equal to 7, B is equal to 4. So when you do this, you get sine of A is equal to 1.124, a bunch of other numbers, which means that there is no solution. You do want to see the numbers that you get for sine of A. Same thing with sine of B. You need to write those out. when you're solving for an angle, before you get the angle, show that part. So there's no triangle because once you get an error, you don't have to solve any further. So that's what happens when you have no triangle or when you have one triangle. Here's what will happen when we have two solutions. So we have angle A, B, and C. And then I'm going to go ahead and anytime that the angle given is acute, you should do this. You should check to see if there's a second triangle. And again, that's when the given angle is acute. You should check. So this is triangle 1, and this is triangle 2. They both have the same given information. The given information can't change. So we just start with the first triangle. Okay, so for the first triangle, triangle 1, we have sine of 40 over 13, sine of b over 16. Again, we cross multiply those two together, and then divide by 13. Sine of b. And again, if I'm going too fast, you should pause it before I go to do the work, because I've done the work ahead of time so that the video isn't too long. When you solve for b, when you do inverse sine of both sides, you should get b is equal to 52.3 degrees. That's the first b value. So the first b value for the first triangle is 52.3 degrees. For the second triangle, you're going to take 180 minus that number. So the second b value will be 127.7 degrees. And as long as these two numbers are not over 180, you will have a second triangle, which in this case is true. So these two values and the original, so the B2 value, the second angle or the second triangle B value for the angle, and then the given A value are not over 180. That means you will have a second triangle. If you add these together and subtract from 180, you get 12.3 degrees. At the top triangle, if you add these two together and subtract from 180, you get 87.7 degrees. Then we just finish off the problem. You must use this because that was the given information both times. So for the top triangle, I will use sine of 40 over 13 equals sine of 87.7 over c. And for the bottom triangle, I will use sine of 40 over 13, again, equals sine of 12.3 over c. And again, you always want to use the given because nothing's rounded there. So we use that here, we use that here, and we use that here. We're going to cross multiply. So multiply these two together, divide by sine of 40. C is equal to 20.2. And again, same thing down here, cross multiply these two together, divide by sine of 40, and C here is equal to 4.3. So that side's really short because that angle is really small. So you can see that you do have two triangles, and then you need to try that for the next problems. I'm going to go ahead and just write the answers in for the next ones so that, or maybe I can do one more problem with you and then the rest of them I'm just going to write in the answers so you can have them. So let me go ahead and write this out, excuse me. So A, B, C, and A, B, and C. The given information, 55, 20 and 18. The equations that you should be using. And again, you should go ahead and do these before me and then just watch it be done afterwards. Since I already explained the first one, hopefully you guys can catch on to this part. So there definitely will be two triangles. Add the angles, subtract from 180. And then finish doing loft signs to finish this off. We do the top triangle in red, so sine 55 over 18. And the bottom triangle in blue. And then I'll just write in the answers that I got. You can put that all into your calculator. Again, pause it if you want to do it ahead of me. And then for the last two, I'm just going to go ahead and write in the answers. Again, you should do them ahead of watching the rest of this video. I'm just going to write in the answers. This is not the order in which I solved for them. This is just me writing down the answers so you can check them. And then the last one, if you do the work for it, you end up getting no triangle. You end up getting sine of A, not sine of A, excuse me. Sine of B comes out to be like 1.20 something, which means B has no value. So there's no triangle.